Hi everybody. In this video, we're going to go through our lesson on literal equations, and I'm going to talk about what that means and how we solve them first. So let's define what a literal equation is. Now, literal equations, they have more than one variable. That's what makes them special. More than one variable. And we see literal equations a lot, actually. Oops, that works. Think of your formulas that you might encounter. For example, area equals length times width, or 1/2 base times height for a triangle. Another one I think of a lot and we see a lot is your rate or your speed is distance over time, right? Or maybe even circumference equals pi times diameter. There's lots of different formulas, but what I want you to notice about these formulas, often one variable is isolated. And when we talk about something being isolated, that really means that's by itself. So in the two examples I provided up above, A is by itself and R is by itself. Those are the isolated variables. Now we can solve literal equations. We can try to find or isolate a different variable, and we will use inverse operations to do this. So use inverse or those opposite operations to solve for, meaning isolate any variable. Get that variable that you are looking for all by itself. So what are the inverse operations? Hopefully, these are starting to become more and more familiar. First set we have is if you see something being added to one side of the equation, you can undo it by subtracting, or if you see something being subtracted, you can undo it by adding, right? These two are a set of opposites. Let's see this color used. Another set of opposites would be if you see something being multiplied. And that could look like an actual time symbol, or sometimes you just see things in front of parentheses or side by side. You can undo that by dividing. And division can be undone by multiplying. And please remember that division includes fractions, right? X over 2 is like x divided by 2. The last set, and this is one we learned last unit, or actually I should say earlier this unit, squares, meaning something raised to the second power, and square roots are opposites of each other. So if you see something being squared, you can undo it with a square root. Also, if you see something in a square root, you can undo it by squaring it. The main key point, what you do, or what you move, whatever operations you perform on one side, you must do to the other. So keep your equation balanced. That is super important. This is going to be a very example-heavy lesson, so you can see lots of different types of equations. And I want you to note just in all of these examples, a lowercase is not the same thing as an uppercase. So lowercase letters and uppercase letters represent different variables. So please just keep that in mind, and don't switch If you see a lowercase g, that lowercase g better be there throughout the problem. Don't switch it and make it uppercase. So if you prefer to write letters, like I'm someone, I don't know why my Q's turn out kind of weird lowercase. I like to write it uppercase. Can't do that here. These have to stay either lowercase or uppercase. Number 1, solve for h. And the equation we're going to solve is h minus g equals uppercase A. So looking at what is going on with h, right? Our goal is to get h completely by itself, and we have this subtraction happening. So I need to undo that by adding this g, not just to the left side, but also to the right. So if it helps you, you can always divide this equation in half through the equal sign to remind yourself that what you do to one side, you have to do to the other. Now, when I actually do this, the g's will cancel on the left, leaving us with just this h. So h is equal to, and then a plus g has to just stay as capital A plus g. So now I have found my solution. H is equal to capital A plus g. And that's my answer. I don't know what any of these variables are, but no matter what they are, h is equal to taking whatever a is and adding g. All right, number 2. We are going to now solve for d. S equals d over t. So this is actually our speed formula. Speed is equal to distance over time. Let's solve for distance. So notice it's distance over time, meaning this is being divided. I'm just gonna write divide. So to undo this, I have to multiply. So I'm gonna actually write my equation down over here. S equals d over t, and I have to multiply both sides of this equation by what's in the bottom. So multiply both sides by t. So when we do this, t times s is just ts, or I could even write this as st is equal to, and the t's will cancel. So d all by itself, rewrite this, d all by itself is equal to speed times time, or s times t. So in this one, we just multiplied to get rid of that denominator. Number 3, let's solve for b, capital B. So B is over C. Let's see. Position is just a little better. B is over C plus 12 squared. And that is equal to 5F. So kind of like in the last problem, the variable I want, B, is in the numerator of a fraction. So it's being divided by this C plus 12 squared. So I'm going to write the equation over here again because I think that's very helpful for me. So B over C plus 12 squared. I mean, this is a lowercase c, by the way, and that is equal to 5F. So to get rid of this denominator, to get rid of this division and get B completely by itself, I'm going to multiply. Now, the weird thing is, what we're going to be multiplying by is the entire denominator. So I'm going to multiply both sides of the equation times C plus 12 squared. So when I do that, the C plus 12 squared in the top and the bottom on the left-hand side are going to cancel. So that's going to leave us with just B, like we would like, is equal to this 5F times C plus 12 squared. And you could either leave it as this term outside of a set of parentheses, or we could distribute it. I could distribute 5F to C into 12 squared. I wouldn't, though. You don't have to. You could leave it just like this. So I'm going to write it all in one color. B is equal to 5F times C plus 12 squared. And this is an answer, if you were working in delta, this is an answer I would accept. Number 4, let's solve for R. This is another formula that should look familiar. C is equal to 2 pi R. So this is our circumference formula for a circle, the distance around the outside of a circle. And if I want to get this R by itself, notice that this is really like circumference is equal to 2 times pi times R. Or I could even really just think of it as 2 pi times R. So if I want to get this R all by itself, we have to undo the multiplication, and I'm going to divide then both sides of this equation by this 2 pi piece that we don't want. So I'm going to move the 2 pi over by dividing both sides by that 2 pi. So that way that piece will cancel on the right, and I will be left with just R equal to the circumference, capital C, over 2 pi. So here, R, or radius, is equal to circumference over 2 pi. All right. Number 5. Let's solve for M, capital M. So K is equal to W squared times capital M plus 4 times Z. This one has a lot going on, right? If I'm trying to get this M by itself, I notice there's this addition here. But before I can focus on the addition, all of this is being multiplied times W squared. So I need to get rid of this W squared first. So I'm going to rewrite the equation again. I just think that's always such a good step so I can see the original before I start doing a bunch of stuff. All right, so divide both sides by that W squared. So the W squareds will cancel on the right. And let's see, I'll move over here actually. And we'll just have K over W squared is equal to this set of parentheses, which are no longer needed. It's capital M plus 4 times Z. Now, to get this M completely by itself, I have to undo this addition, which means I will then subtract 4Z from both sides. Here's where it gets a little bit interesting, because I have this K divided by W squared, right? That's its own number, and we're going to subtract away from that 4Z. And that is equal to M. So please do not forget that this is just a number that we are then going to subtract 4Z from. So this would be my final answer. Oh. All right. Number 6. Oh, this is one of my favorites. Oops. We are going to solve for G. So the equation is M times G, capital G, plus R times capital G is equal to negative B. And I want you to notice that this G is in not one, but 2 terms. So I can actually take this and I can factor. I can factor the G out of this equation. So I'm gonna, again, write it down here. Mg plus R times G is equal to negative B. And on this left side, I can factor out the G. Can pull it out. So we now have G times what's left would be just M plus R. And that is equal to negative B. So we kind of now have G in a better spot to isolate it. So what do I do from here? Well, this is G times M plus R. So let's now divide by the entire piece we don't want, M plus R. So I'm going to divide both sides by M plus R. We can do this. It's just a number. So I'm going to divide both sides by M plus R. So it will cancel on the left-hand side, and we will be left with capital G is equal to the negative B divided by M plus R. You don't really need parentheses if it's the only thing in the denominator. All right, I like that one. Number 7 is another good one. So we're going to solve for A. And we have 5 over y is equal to x over a. So when I see this a in the denominator, that hurts my heart. We cannot have a variable in the bottom. So what can we do here? And you can actually think back to something you hopefully learned in middle school called the butterfly method. When you have these two fractions equal to each other, you can essentially cross multiply. So I know that 5 times a, that is equal to, and I'll go the other way and cross multiply y times x, or I'm gonna write x times y. So 5 times a is equal to x times y, just multiplying across like a butterfly. And now, writing this a little bit better, 5a equals x, y, right? So now I have an equation I might be able to more easily solve. And remembering that this is just multiplication here, I can undo this multiplication by dividing both sides by this 5. So the 5s will cancel, and this tells me then that a is equal to x times y divided by 5. All right, we're gonna do one more. You could do that in a way longer way if you wanted to. You could multiply both sides, the original equation, multiply both sides by a, and then you would have a times 5 over y equals x, and then you could divide by 5 over y, which is not fun. So that is essentially using this butterfly method. Number 8, solve for b, and this should be another familiar formula. And this is our last one too, by the way, if I didn't say that. A squared plus b squared is equal to c squared. So I want to solve the Pythagorean theorem for b. So how do we do that? Well, first, let's notice that b is being squared. So that's an issue. But before I can even think about taking square roots, let's get rid of this a squared that is currently being added to this side of the equation. So let's rewrite it first. So a squared plus b squared equals c squared. First thing I'm going to do is subtract a squared from both sides. So this then will cancel on the left, and we have just b squared is equal to this c squared minus a squared. And now I almost have b all by itself. I just have to get rid of the square. So in order to do that, I will have to take the square root then of both the left and the right-hand side, which tells me then that b, because the square and square root will cancel, is equal to plus or minus the square root of c squared minus a squared. No, 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 the square and square roots do not cancel here because those two terms are being subtracted. It's not how it works. The radical cannot distribute like that. Only if those terms are being multiplied. So this is our answer. And oftentimes when we're talking about like real lengths, you're not going to even consider the negative root. It would just be the positive square root, but let's consider it could be positive or negative when we're solving. Please let me know what questions you have. This is a hard skill. It takes practice, practice, practice. You will make some mistakes, you will learn, you will grow. Let me know how I can help.